All right, now let's look at the last section of the 6.5. Okay, we introduced the last two property of logarithm. It says if m equals n, then log a as the base of m equals log a as the base of n. Okay, and vice versa. If log a as base m equals log a as base n, then m equals n. So here m, n, a are all positive numbers, and a is not equal to 0, not equals 1. Okay, a is not equals 1. So that's the last two properties of logarithm. So in this section, we total learned 8 of them. All right. And then how to evaluate logarithm whose base is neither 10 or natural e. So we're going to learn a theorem is called a change of base formula. Okay, change of base formula. So if a is not equals 1, b is not equals 1, and m is a positive real number, and then we have this property. Okay, log a as the base m equals log b as the base of m divided by log b as the base a. So what it says is, when a is not in a natural e or not a 10, right? Not a natural log, not a common log, and then we can change the base to make it become either a natural log or common log. Okay, but as the ratio of log b as the base of m divided by log b as base of a. Okay, let's look at an example that help you understand this formula. So that's basically say the same thing. We can use common log or natural log to evaluate any log when the base is not natural e or 10. Okay. So let's look at example. Log 5 as the base of 89. Okay, and then we use change of base formula and then round answer to 4 decimals. So log 5 of the base 89, we can redo as either common log, okay, log 89 divided by log of 5. Okay, let's look at the next slide. So log 5 of base 89, we can do either use a common log, log 89 divided by log 5, or we can use a natural log, log 89 divided by log of 5. Okay, and then we can use a calculator to evaluate it, or we can just leave like that. Okay, so how to use calculator to evaluate this? Okay, I'm gonna show you the calculator. Okay, so let's try common log. Okay, this is symbol for common log. Okay, if it doesn't specify the base, the default is 10. We call it common log, right? Log 89, and then close parentheses, right? And then divided by log of 5, close parentheses, and then press enter. Okay, if we keep 4 decimal, we round it to 2.7889. Okay, let's check the PowerPoint. 2.7889, right? All right, let's try use the natural log, which is len right here. Okay, len of 89, close parentheses, divided by len of 5, close parentheses. You will see they got exactly the same result. Okay, we round it to 2.7889. All right, that's how to use change of base theorem to evaluate any log in the calculator. Okay. All right, let's try the last one. Log square root of 2 as the base of square root of 5. So we can either use the common log or natural log, okay, the ratio of the two log to evaluate this. Okay, so that's equivalent to common log square root of 5 divided by common log square root of 2. Or we can use natural log square root of 5 divided by natural log square root of 2. Okay, let's look at a calculator, how to do that. Natural log is here, right? Common log here again. So common log square root of 5 Okay, in order to call square root, we do second square, right? Square root of 5. And then the cursor now still under the roots. You have to use the arrow key to move the cursor out of the square root and then close parentheses. Okay, that's the common log square root of 5 divided by common log square root of 2. Okay, same thing. Use arrow key, get out of the roots, and then close parentheses, press enter. Okay, let's try natural log, see if we get the same result. Len of square root of 5. Okay, use arrow, get the cursor out of the roots, and then close parentheses, divided by len square root of 2. Okay, use arrow key, get the cursor out of the square root, close parentheses. Okay, so if we round it 4 decimal, that's 2.3219, right? 2.3219, right? We got the same. Okay, that's how we use change of base theorem to evaluate any log, okay, which base is neither natural E nor 10. All right, so this is the last slide of 6.5, and then we finish today.